Yours Peels, and this is another episode of 3D Printing News Unpeeled, courtesy of 3dprint.com. So today we are delving into optical fiber. So this is a truly mega international research project that ropes together people from Korean, British, German, and Australian universities and research institutes, people working on this. Monash University, the Ludwig Maximilians University of Munich, Pohang University in Korea, Jena University in Germany as well, the Imperial College London, Leibniz, like a whole bunch of people from all over the place. They're working on this really, really cutting edge research where they're essentially making a nano printed optical lens and putting it on the end of a fiber optic cable. The idea is that they can then focus this light in a more precise way using this nano-printed lens. Specifically, what it's doing is it's mitigating these chromatic aberrations. Now, in order to do this, it's called an achromatic lens, also called a meta lens, apparently, and it's made out of really, really thin polymer nanopillars. And this is put on a nano-printed tower, and that is attached literally to commercial optical fiber that transmit our internet beneath the ocean and all this other stuff. The idea is that it's really, really efficient at focusing light, a really, really high resolution, and it's only 100 micrometers in diameter. This lens allows you to put different wavelengths of length to be focused on a single focal point. Now, what they think they can do with this lens is to, for example, update and change endoscopic imaging systems. So endoscopic imaging systems is a way now to, in a minimally invasive way, get something inserted into an orifice or get something inserted into a surgical area to get imaging of a area deep within us humans. But maybe we can get improved or even more minimally invasive endoscopy type treatments or endoscopy like kind of treatments for humans with this. What they also think is maybe this has application in lasers assisted therapies. Fiber optic communication is, of course, something we all thought of, and also fiber sensors, where we can make a whole bunch of sensors with this technology. This is it's wonderful to see so many fine universities and research institutes from all over the world working together. And these are one of these things where we can't really see what it will mean for us, but it has. This is potentially very, very high impact for us in the future. And the idea to make something like this in a commercially available thing is, I think, a truly very exciting thing. And this is one of these things where, yeah, it could span like can get totally different kind of cameras that can tell all sorts of different sensors. It could really make these IoT-like sensor type packages really deployable across a lot of things, or it could do tons of stuff we've never really thought about. This is one of those things. So I think it's brilliant to see this kind of cooperation and something this groundbreaking emerge from that. The next thing is, well, it looks, at the first glance, it doesn't look very new or exciting at all. It's a guy called Eric Olson. He's also called Janky Eric or Jarek. And he is making pump holders. So these are holders for that you can attach to certain bicycle frames. And they hold like these kind of emergency bicycle pumps or other things to pump up your tire if you're stuck in the middle of nowhere. So these are specific models being made for very specific bicycle pumps. The things itself, you can buy it from him. It's about 5 grams the part. There's also a part with adhesive on it. This is just the part itself. It's just 3D printed. I think it's just on a regular desktop 3D printer, what it looks like. This is the part with adhesive. So there are versions where you can just buy this thing, you take off the 3M adhesive, and you just stick it on your bicycle. Or you can just buy this loose, and then you can use screws and things to stick it on. Now, he prints them in Bellingham, Washington, where he lives, and he sells them for the affordable price of $24.99. But of course, if you know what it's like, the cost of printing these things is using nylon X. This is using nylon X carbon fiber, which is a matter hackers filament. That's it's like 20% loaded CF loaded or short carbon fiber loaded. So that'll give you quite a stiff kind of result. And so this in and of itself, it just seems like a really good product. It's a really good product for people with that specific frame, with that specific bike accessory. And it's just a beautiful business. And I think we are seeing a lot of these parts float around in Thingiverse and stuff like that, but we are not seeing enough people start a business like this. where this guy he's somebody to know in the bike community. He understands what the bike community wants. He's a biker himself. He uses these things a lot, and he's going to design perfect solutions that are affordable and that he prints at home for this community. I think there should be many more businesses out there that maybe as a side business or as a business that somebody starts from their living room could grow out to be more. I really want to see more businesses like this. I think it's a fantastic business to make these specific products that work well. And I think holders are a product that we all know will work very, very well with 3D printing generally. The next thing is something that it's a couple of days old already. And what happened is there's a company called Virtual Foundry. They make like bound metal kind of products and filaments and stuff like that. And they have been working on, and also a maker independently of them, a YouTuber and a maker independently of them, have been working on this debinding and sintering process. Normally, you would need a industrial kind of debinding setup and kind of an industrial type oven for the sintering. This is, by the way, very tricky. You don't want to do this kind of stuff at home, or I wouldn't want to. But somebody who is definitely doing a lot of work in this area has, together with the company itself, Mr. Highball, he's come up with a way to essentially use a microwave kiln to do a lot of the work of making these metal printed parts using bound metal filament. What he's doing is using the aluminum 6061 filament from Virtual Foundry. And he's using like essentially what's called a microwave kiln. It's known by a different couple of names as well. But essentially, it's kind of a thing usually made of ceramics, or it could be made of different types of material. It's like a heating element. In this case, it's made out of partially made out of silicon carbide. What you do is you put your to be sintered part inside of it, and then you put it in a commercial microwave, and then you blast that microwave at 600 watts. And then it will do this work before you, and you don't need an oven. And potentially it could actually be faster, it could be simpler to do depending on where you are, or it could be much more accessible to a lot of people because they don't have the commercial ovens, but they do have a microwave that could do this kind of output. To me, what Highball is doing on his YouTube channel is very exciting, and I think it's really wonderful that somebody is taking up this challenge. Now, this is not something you want to 1, 2, 3 try at home. You have to be very, very careful with this, by the way. I just want to tell you that. But I thought this was a very exciting development to really democratize metal on home 3D printers, and really to understand the capability of trying to get everyone to get metal parts could really be real with this development that we're seeing. Also, aluminum is a very difficult material for us to print generally. So it's wonderful that they're starting with this. But also these kind of guys, these Virtual Foundry guys, they have copper, iron, 316L, Inconel, tungsten. So this could really, vastly improve the repertoire of a lot of people in, I don't know, again, I don't want to do this at home, but maybe in a kind of office, semi-office environment or in a workshop, you could really find a very new, very inexpensive way to get to metal parts. So yeah, that's the news we have for today. Thank you very much. My name is Joris Peels, and this is another episode of 3D Printing News Unpeeled.